Greetings everyone, Dan Featherstone here. Today we have another webinar presentation. Today we're going to be talking about the Pentek Intellidrive, the inputs and outputs and the programming of it. Essentially what we call page 16. Starting off with though, we always like to talk about other opportunities for learning. We offer you many. If you go to any of our websites under the resource tab, on the left hand side you'll see learning opportunities, and it will bring up all of these that we're just going to quickly touch base on. First and foremost, the Pentair Learning Center, where you're probably watching this webinar now as we speak. It also gives you modules to learn at your own pace, interactive modules, pre-recorded webinars, etc. They're all right there, and the best thing about this is there's no charge. So don't be nervous to sign up or tell your friends about it and let them get in on the action, so to speak. We also have the Facebook page. You can follow us there if you'd like. Every company, we have some sort of role program. We're no different. Pentair dealer program. Two things I'd like to point out about that is the labor agreement and the extended warranty program. Be sure you're taking advantage of these if you can. Details can be found at www.pentairprodealer.com. Customer Access Portal. Dealers and distributors, you can go online and find out information. You have 24 access to pricing, availability, order status, etc. Give Miss Amy a call at 866-880-3771. Of course, last but not least, the good old factory schools. We do offer them in the spring and in the fall. They are hands-on labs often involved with these, especially when you come to Delavan. We don't like to let you sit for long. We like to keep you moving and interactive with the equipment. Plus, there's, of course, in Delavan, there's the factory school, which a lot of guys like. For more information, like I say, go out to our website. You can sign up. Definitely worth the investment. So today we're going to be focusing on the Pentair Intellidrive as a variable frequency drive. And more importantly, what can it do besides just be a variable speed drive and control? A lot of people look at that box, and I think with the past modules we've done one on troubleshooting, we've done one on basics. So today we're going to talk about what more can it do other than just be a variable frequency box. So a lot of people view that as a mystery box. What are these inputs and outputs? What can they really do? How can we hook them up? We get that question often in customer service. And if we're looking at it, we're looking at the inside here. What we're focusing on is those three connections right there. Output, the input 1 and input 2. What can we do with these? And one thing I'd say is that yes, we do have a limited number of connections. A lot of customers will say we only have 2 inputs and 1 output. And that's correct. This is a simple device. It's not intended to be a commercial or industrial product. So we do limit the number of inputs and outputs to keep it clean for the installer and for those that work with it. First of all, what I want you to understand is that any inputs are all digital, meaning that there's either voltage or no voltage, a signal or no signal, on or off. So when the input sees voltage, it's now saying, okay, I see the voltage being applied or I see the voltage removed. What do you intend for me to do? So, for example, when it sees current, are you trying to tell it to run, fault, or look at a different set point, for example? So looking in the manual, we do tell you exactly what digital 1 and digital inputs 2 can do. What you have to kind of decide is what you're trying to do, intend it to do. Now, when you look at the inputs, understand that the inputs can accept 24 volt DC all the way up to 230 volt AC, so 115 or 230 volt. An input is simply looking for voltage, is all it's doing. Not load, just for a signal. Once it sees a signal, then you answer the question, when I energize this circuit, I want A, B, or C to work. Meaning tell it to stop, tell it to run, or tell it to look at a different set point for pressure. Outputs. Output is just a dry contact. It's going to close upon a command. So inputs, what I like to tell people is an input tells the VFD to do something. An output, the relay will close because it's communicating what the drive is doing based upon what you asked it to monitor. Now, it accepts up to 5 amps, either DC, 24 volt, or up to 8 amps on 230 volt or 115. but it's non-inductive load. It's not intended to be a relay to start a pump. You do so, you will damage the actual contact. If you are to try to start a pump with this, what we recommend is you use a mag relay. So you would have 115 or 230 volt coming into the circuit. You give it a command to say, when the pump is running, I want this output to close. So it starts the unit, the output relay closes and passes voltage down to a mag relay, which then snaps shut and closes the pump start relay and energizes the pump. So there, like I say, the inductive load is taken off of our box because we have a pump start relay. Do not try to use our unit as a pump start relay, though, directly. We always laugh at this, and we tell people in customer service when you call, read the manual. That factory manual does have good information. Page 16 is chock full of good drawings and information and wiring specifications. So read that factory manual. There's a lot of good information in there. Now that being said, let's explore a little bit here. When we look at it, we're looking at, this is one of the first drawings on page 16 or 17. It will tell you an example of an input with an internal 24 volt supply. Now, our PID unit does have 24 volt support up to 20 milliamps because the other 20 are used on our transducer. So here you can use it for signal strength for one more device. And what we show you here is a jumper going from V negative to input 1 negative, and then input 1 positive going out to the control, be it a switch, be it a float switch, whatever, going into V plus to complete the circuit. Good example of this might be a float switch. So now what we need to answer the question is that when the PID sees this current, when it sees the signal, what do we actually want it to do? So we showed you the circuit, how we have it programmed. Let's say it's a float switch. If it's a normally open float switch, it won't pass current. So often what we recommend is if you want a run command, you want that to be a normally open float switch. So as the float rises with the water, say in the cistern, it gets to a fill point and the point snaps shut and applies voltage, telling the unit it's safe to run. So a lot of times when you're planning these, first of all, I find my drawing, or I draw out the circuit as I see how I want it to work. As we saw in the previous page, we're using the 24 volt onboard power supply, and we're using, I said, a float switch. Then I gotta ask yourself, when it sees voltage, what do I intend it to do? Run, like we just discussed? Maybe it's a fault. Maybe it's a water sensor, that when the water sensor gets wet, it sends a signal to stop the pump. Maybe it's a flow sensor, that when it sees demand going to, say, a different zone, when it trips zone 3, oh, that's a drip zone. Let's lower the pressure down from 60 down to 20 psi. So what do I want the drive to do when it sees voltage? And you have the 3 basic choices there. So again, let's get back to our float switch description. So here, when my water cistern is full, the points have closed, and it's passing current down to the drive into input 1 using the 24 volt power supply on board. As we pump water down, the float will start to tip with the water level. When it gets to the down position, as you see here, the point's fully open, stopping the current flow. Now that takes away the run command. What this is a run command. So it sees no run command, it will stop. It doesn't mean it faults. It just means it stops because the drive has no more run command. Okay. So this is one example we can do. Another good example is a safety switch or a dead stop maybe. That this button would normally be open, so there's no voltage passing. But let's say we're using this, that we're trying to fill a tank as a reservoir, and we see that it's starting to overflow and we want to stop it suddenly. You push the button, now the button snaps closed. Voltage is now applied to input 1, input 2, however you programmed it. It sees the voltage, and we programmed that to then fault. and it will tell external fault, telling you that it sees voltage applied to that input. Now, unlike the run command, if you program the faults here on the inputs, they will show as an external fault, and it will be a hard stop, meaning that because we do not know what you're programming, anytime there's an external fault, it's a hard stop, meaning you have to reset the safety first and then hit fault reset and auto start in order to do that and get the VFD running again. Now, we're looking at how to program this, because the first thing we always have to do is, of course, wire it. So here's our wiring diagram. We did our wiring, but remember, that's only half the steps you have to do. Now we have to make sure we properly program our Pentek Intellidrive to do what we want. In this case, say we want it to be a float switch, whatever, we go and we're going to have to enter in the password if necessary. So you look at the screen, if you see the little skeleton key or the Franklin key in the corner, that little icon tells you the unit's locked. If that's the case, you enter in your password. Remember, the password default is 7777, 4 sevens. Then go into main menu. So hit the password key, put in your password, enter, then press the main key. Then you're going to arrow key up or down until you get to I/O, which is input and outputs. We will then hit enter and then the arrow key up or down until we get to the input that we want to program. So for example, here we're hooked up to 1, so we go to input 1. Then press enter to gray out or highlight the box, because it probably says unused at the moment, and we're going to then decide, do we want it to run, fault, or run at a different pressure. Once we decide that, hit enter to lock it in. Now once you have that, my answer is I always hit the status key, which is the button on the bottom right, which takes me out of the menu and brings me back to the main panel there that we're normally accustomed to seeing, and I would hit auto start and then test to see that I programmed it properly. So remember, when we're working with inputs, one half of the battle is to ensure that you have your wiring done properly, but the most important thing is you have to tell the drive what we intended to do once there's voltage applied or no voltage. Okay. Now this is a very typical one you'll see. This is our water detection device. Now, one fair warning I want to tell you is that I told you we only have 20 milliamps on the board. The other 20 of the 40 is already used by our analog input, which is our transducer. So if you intend on trying to hook up more than one of the water sensors, you can't support it with our onboard power supply. It will do one, but it can't do 3, 4, or 5. And people might ask, well, does someone really try to do that? Yes, we've had customers try to do that. Because our milliamp output is limited to 20 milliamps, only one trigger device can you run off of our input 24-volt power supply. But don't worry. Remember, I told you those inputs can look for voltage 115 or 230 volt as well. So we have other options for other connections. So in this case here, the water sensor, when the probe set that's on the bottom of this unit has water touching it, it makes the connection and applies voltage to input 1. We would then set input 1 to external fault. Because if I have a pipe break and I'm sensing water leaking everywhere, the source of that water potentially leaking everywhere, of course, is going to come from the pump running. So I want to stop the pump. So in this case, we definitely do want a hard stop. So this is just one example of one device that can be hooked up to this unit. Now, if in the case, for example, we want to hook up a secondary float, again, we want one that's normally open, one down, and when the float rises, it closes and passes voltage to the unit. And this is going to be my run command, for example, in a cistern. If we have a body of water that maybe a secondary pump pumps to fill, or maybe we have water delivered because we just can't develop a decent well. So we have a storage tank. I want the VFD to only run when there's water safely in the tank. Now, in the earlier picture, I just showed you the water sensor took up the input 1. So we're going to hook up to input 2 now using 115 and a float switch. And what you see there is input 2 coming out, and say for example it's the black wire, the float switch. Then in the float switch we have the white wire, which then I would connect to the white wire of, say, a pigtail, 115 pigtail cord, and then I would then connect the black of the pigtail cord into input 2 positive to complete the circuit. Now in the down position with the normally open, it will not pass voltage. When I lift the float, the point should close, and then voltage should be applied to input 1, which we would then program to run. So the other thing we have to remember is, because we're now using external voltage supply, remember you do have to plug it in. I chuckle a little bit because I've had customers do this and they forget to apply the voltage. So just mental note, in here, not only do we have to wire the PID box, we also have to make sure we apply voltage, often like I show here, by plugging it in. And then we have to remember to program it. So input 2, we would go into our main menu, if need be, enter our password again, scroll down to input, output, I/O, enter, scroll down to input 2, enter, to highlight the box. It'll probably say unused, of course, because we're not using it. And then we're going to scroll till it says run. Hit enter to save it, and then status button to pull out again. So we're back to the main menu. Now this is a closer look I'm showing you here. In this case, we have both the water alarm now hooked up, borrowing voltage from our onboard 24 volt power supply. Because we did that, now we have our float switch, which is a secondary device, hooked up there into input 1, taking 115 from the wall circuit and bringing it into here to energize the circuit when the float is up to give it a run command. What we're showing here on this slide is our alternator. Our alternator, first of all, is a simple device. A lot of people kind of say it's dumbed down or it's limited, and the answer is true, because more importantly it's cost effective. Can you go out there and get alternators that you can set in times and such? Absolutely. It's all what you want to pay for. So this is a very simple operation. So first of all, our alternator has its own power supply that powers the clock. So in this case here, when we plug it in, the minute you plug it in, we start a 24-hour counter. And at the end of that 24 hours, it's going to make relays on the left lag and the relay on the right lead. 24-hour passes, and then 1 and 2 become lead, and 3 and 4, the connectors on the right, become lag. So if you're trying to shoot, for example, for a midnight change, you would have to plug the unit in at exactly midnight. But that being said, it's not a bad unit. It's a very good alternator. It's a simple device. And what we're doing here, as we show here, we are using the voltage off of our PID drive. So if you want to use a water sensor in conjunction with the alternator, it might be difficult to do so because we're taking that power supply away already. So if we're using the alternator, we show you here, you run a jumper from V minus to input 1 or 2 minus, and then the 2 wires coming in from the alternator go to input 1 and the V plus. So that alternator, though it has its own power supply, that's for the counter and to control the relays to snap them open and close. Okay, it does not send voltage signal down into our actual PID drive. We're still borrowing the onboard power supply, as you see here. Now, the second VFD drive, you would then wire it the same way, but programming it would be different. So for example, this is going to be a run command. So basically what we're going to tell it is, when we have these wired up, we're going to go into our main menu, and to get in there, remember you might have to put in your password again. So put your password in, enter, then go into main menu, scroll down to input, output, I/O, enter, and then scroll down to say input 1 or input 2, and we're going to make that look at a different external input, a pressure point, a different pressure setting. So for example, how these are often used is a dairy operation, for example, has 2 5-horsepower pumps, and they want to equally wear them. So on day one sees the charge and it's going to run lag because there's voltage going down to the input, and that voltage tells it to look at the secondary input of pressure setting. So it runs at, say, 55. And it will maintain 55 psi when needed, but it will not turn on until the pressure point drops to 50. Now, if you look at the second drive number 2, it doesn't see the voltage, so there's no voltage on the input to influence it, so it's going to run at the full 60 psi, turning on at 55. So what happens, you have a large demand, so the pressure drops down to 55 psi. Cows are coming in for the first morning milk, and they start to drink quite a bit, and so the pressure is dropping. There's so many cows that the primary pump continues to lose pressure even though it's running because it can't keep up with the demand. So it goes from 55 to 54 down to 50. The secondary pump now sees 50 psi and turns on, boosting it back up to 55. Why only 55? Because I don't want that secondary pump running that long. So it's going to maintain up to 55. When it sees the demand wane, and it can maintain 55 steadily, it will then turn off and go to sleep. The primary pump, remember, is still running. If it can maintain the pressure, or more importantly build pressure, it will continue to run until it hits 60 psi, satisfies the condition, and it too goes to sleep. Now, that's how lead and lag works. The important thing is alternate. Now what happens is 24-hour passes, my alternator alarm clicks and switches. Now the secondary pump that was lag is now the leader and will run first. The reason for this is really to make sure we wear both pumps evenly. That's the goal. Now, can I run lead and lag without an alternator? Absolutely. But the lead will always be lead, the lag will forever be lag. A lot of customers, they like to switch them so they wear them more evenly and get more longer life out of the pumps. Now, let's talk about the output for a moment. And now what we got to answer is we want to run the output. When something happens, and remember, the output is going to reflect what the drive is doing. So when the drive faults, when the drive runs, when it does those things, I want it to signal me. So before you wire it, one of the things we want to say is the unit then has a fault or does it run? A good example of this is chicken farmers. Chicken farmers are often very concerned when a pump goes down because I've been told that depending upon the operation, they can start losing livestock within 3 hours because the misters are down. So it's very crucial for them to maintain pumps. So an output, unlike the input, tells you what happened to the drive. So remember, an input tells the drive to do something, an output tells you what the drive has done. Is it running? Has it faulted? It's important to remember also that you can use the onboard voltage to do so, but it's only 20 milliamps. So I typically tell customers, though you can do it, most outputs are going to be 115 or 230 volt, but it's non-inductive load. Do not try to start a motor with this. You can trigger voltage to go down to a pump relay and start a pump that way, but the inrush current will damage our relay. So in this drawing here, we are going to intend to use the onboard. Maybe it's a simple light, a 24 volt light with an indicator on a test board. We just light that light up to show the unit is running. Here we have our V1, our voltage we're going to the output, O1 plus here as I show to the left side. Going to the right side. We have the output then going to the lamp, and then the other output of the lamp going into V plus to complete the circuit. Now again, when you hook up an output, wiring it is only one half of the issue. The other half is now I have to tell this unit what I want it to do. So again, we might have to enter a password. If you see that little key symbol in the corner of the screen, that tells you it's locked. So hit the password key and enter in the password and enter. Then hit main menu. We're going to arrow key down again to I/O, input outputs. We're going to arrow down to the output now. And now we want to press enter to highlight because it will say unused. And do we want to then decide, is it going to be a run command? So anytime this unit runs, it will close this relay. Or do we want it to be a fault command showing that the unit has stopped running for some reason and it's now sending a signal that there's an issue with our pump or our control? So once you've decided that, hit enter again to save it. And then I, again, always like to hit the status key to take us right out to the main menu. Can you hit the back button to get there? Yes, you can. But I always find it much easier and quicker to hit the status key in the lower left-hand corner of the keypad. So in this example, we are again using a lamp or maybe a siren and 115 voltage to charge it, and then use this to indicate the status of our unit. So here we have our pigtail, plug-in pigtail from a 115 outlet going into O1 plus. Then we have the white of that cord going into one of the wires off the light bulb. The other side of the light wire or the pigtail from the lamp goes into O1 plus to complete the circuit. So now we told our unit that when the pump is running, I want that to close, and it's going to energize the bulb, giving us an indication the unit is running at the time. Or I set it to fault. So the minute a fault is thrown, it lights up a red light telling me, hey, my pump is faulted, or my motor is faulted, or the control is down. So it sends us an indication, giving the farmer a heads up to get down there. Now here we show the wires. Now the first thing, whenever you're wiring a light, for example, in this case I'm using a trouble light, I always first connect my grounds together. So I have my cord I'm plugging in, or I'm pulling it off of a power supply. I'll do my grounds first. As an electrician, you should always be working with electrical. Start with your ground. Second thing you would then hook up is your neutrals, okay, because that helps keep you safe. Then your two black wires, your black wire coming in from your power supply goes into the relay. The black wire going to the lamp goes into the other side of the relay. So when the relay closes, it completes the circuit and passes voltage. Now, first and foremost, and I should mention this earlier, but I'm going to mention it now and I'll mention it again. First of all, you're not an electrician, so there's no shame in asking for help. Make sure you obey all local codes and make sure you obey all local ordinances. So it may not hurt to get an electrician involved in some of this wiring, okay? So we have it wired up here. We have it plugged in, so now we have the circuit energized. So when that unit goes into fault, that relay would close and we would see our red light giving us an indication that the pump has faulted. Or maybe it's a green light and it's a run condition letting us know that the pump is running to our satisfaction. Okay. Now another thing you can do is you can use a mag relay. Now granted, this is an older mag relay, but it's same way. We have it set where we have a line coming out going into our power supply, from our power supply going into mag relay, from the mag relay going into our relay to complete the circuit. So that when we want, say, a run condition, we set it to close that under a run condition. The pump starts up because it sees a pressure demand, it closes the relay. We send 115 volt down to the mag relay, this magnetic relay, which energizes the coil and pulls the pump circuit closed, allowing the pump to start. By doing this, remember, this is the way to do it. We take that inductive load off of our circuit and put it on the mag relay or the pump relay, which is rated for the horsepower and amp draw of the pump proper, so we don't damage our unit. Now I know that was kind of quick, a little bit of it. Here's a few answers to remember. When you're looking at the drive, you're really just limited to some simple on and off commands basically, but you're not limited that greatly. You have two inputs, you have one output, and you'll be amazed what customers can do with it. Now, we referred to page 16. Page 16 gives you the drawings. Page 17 gives you good information on how to program it. But I'm going to tell you this, never be discouraged and feel you can't call customer service. That's what we're here for. That's what we want to do, is help you and make sure that you are able to do these things. We refer to manuals because I can tell you personal experience. I'm the type of guy that I will read the manual. I'll try to make sure I understand it. Then I'll actually draw out my circuit. And people think I'm kidding, and if you've ever come to my classes, no, I do. I draw the circuit again just to make sure, because now I'm doing something tactile. I'm physically making the circuit on the drawing. And then I will physically do the circuit, wire it together, and then make sure my notes are all right, and then I test run it. So a lot of times when you're looking at how you program a drive, for some people it's good enough just to read it and they can go right and do it. Some people like me, I have to do it, read it, draw it out, think it through, and then physically do it, and I'm good. But either way, however you do it in any of this process, remember, you always have customer service. So again, read the factory manual, because you know what's on the back of that factory manual? There's the customer service number. Don't be afraid to call us. The last thing and the last takeaway, like any of our webinars, these are always works in progress. So reach out to us. Let us know what you think. If you have questions, if you want to see a certain product highlighted, if you have certain processes, or you have questions and concerns, give us a shout out. Get us an email at training.institute@pentair.com, or give us a jingle to 800-680-6956. Thank you very much. This is Dan Featherstone. You guys have a great day.